basically interested in doing what I do and running BBSs. And they're like, what devices are best? It's like, well, if you're here in the States, there's no reason that you need to buy anything other than the go for retro SD device simply because of the things that I mentioned earlier. You got the real time clock, you have the external power supply or power port, you have the 12 partitions, which basically anybody's going to run a BBS is going to at least have more than five or six just to
Right.
have stuff segregated, right?
Right.
So yeah,
Well,
I really appreciate your hard work on them.
no problem. I was just looking up here a little bit to see if the mark, yeah, there it is. So the only thing is, so if you do get the environment set up to where you can compile it, here's where you can change. So let me make this a little bigger here so everybody can see this. So everything about the code is it's all set up uh, with with kind of variables so that you can change things. So you've got, what's the device here, the microcontroller, does it have a bootloader? Yes. Here's the device ID that I was talking to you about. That's this signature byte. There's a debugger on it. You can turn on the debugger. It's got a serial port and whatever. And then there's all these various loaders. So here's Epic's fast load. Yes. I don't think Jiffy DOS. Jiffy DOS, you can't turn Jiffy DOS off. It's just there all the time. And then there's also a version of it that can use two SD cards. I don't have that hardware, but it does exist. I don't think anybody makes that particular unit anymore that has two SD cards. But if you look down here, you'll see config max partitions. And so currently, micro IEC 3 is set to 20 partitions. So the maximum is 20 partitions. Um, and obviously, you can try and bump that up. Um, and it looks like I may be wrong. I think I mentioned earlier that the RTC, uh, oh yeah, it's the software RTC. The software RTC is enabled, but there's another one that is a hardware RTC. So we can, let me look here and see, trying to think, one of them would be maybe the embed, which is an older device. So let me see. And it has, yeah, see, so what you basically need to do is there's a config underscore RTC underscore whatever that number was, 1307. So just put 1307 equals yes. I can look up which one it is. I'm sure one of these has that as a device, or I mean as an option. But you just put that configuration in there, rebuild the unit, and boom, you get your you get your RTC that you want. So I think the big thing that I want to make sure folks know is that the one of the things that bothers me, yeah, here's the thing. So it's the code base is different, but it's inspired by MMC2IEC by Lars, and I'm not even going to try to say the last name, but there you go. Um, but one of the things I want to make sure that people understand about the unit is was there was no way it was ever going to be a 1541 emulator, right? Because it just that just never was the that was never the goal, because there was no way that the hardware was going to be able to support that capability. Um, but it was designed to be a portable drive along the lines of like a CMD hard drive, right? Um, and so basically a mass storage device, primarily a device where IEC protocol or DOS compatibility was enough, right? So if you had a program that was primarily um, needed to be compatible with Commodore's DOS, then SD2IEC was going to be a good fit. If you really needed a device that was going to be compatible with a 1541 at the hardware level, then this device was never going to fit the bill. And I think a lot of those um, folks who sold those, tried to make a quick buck selling those devices, 10 or 12 years ago, I think they were the ones that kind of created the problem, because they marketed the device more or less as a 1541 replacement, which was really that was a poor marketing idea. It is a replacement for a 1541 in some cases. Like if you normally just load files off of disk, basic programs, one filer, stuff like that, it works fine for that. But if you're going to do demos, if you're going to do geos, it actually works with geos now. But but if you were going to do heavy, um, the software you're going to load makes heavy use of the CPU inside of the 1541 drive. That was not going to be a good idea. So it is a major annoyance of mine when people are like, oh, the SDC is so horrible because it doesn't emulate a 1541, and I'm thinking that was never the goal. The goal was a mass storage device, and I think it's even written at the top of these pages right here. It's um, yeah, SD2 to Commodore serial bus interface controller. So it was never designed to be a 1540 emulator. And so I would encourage everybody, if you ever see people saying, well, it's a terrible 1540 emulator, I'm like, well, yeah, it obviously is, because it was never, that's like saying that that dog is a really bad cat, right? It's there was no way that was ever going to be the case. Um, and the other one was it was designed to be very inexpensive. It was designed, 50, 30, 50, 30, 40, $50 US was really the sweet spot. I think other now obviously time has moved on, and so there's like the Pi 1541, which is a great option. I know the guy that wrote that code, and that's a really neat thing. And of course, when Pis are not in super short supply like they are right now, and they're $35, that's a really good deal too, right? Stuff it in a little 3D printed case, and you got yourself a inexpensive true 1541 emulator. Of course, devices like the 1541 Ultimate and I think Chameleon has those are really cool devices too. But then again, they're hundreds of dollars, which that's great, but you're not going to have one for every one of your computers. Like this device was designed to be cheap enough to where you could simply embed it into each one of your units. A lot of people, when they install it into a Commodore 64 or VIC-20 or Plus 4 or whatever, well, not a Plus 4, but like a VIC or a 64 or 128, they put some double stick tape and they mount it right above the cassette port, right? So you just kind of have it right there where the cassette connector is, just a little ways in, so you can still use the cassette port. And I think that's a good sweet spot for it. So as long as it's used in its proper, um, as long as it's used for what it was designed to be used for, I think it works really well. Um, and then if you need those 1541 emulator kind of functions, then obviously, um, you know, then uh, then you got to go buy those other options. So there you go. Um, I did bring up the example file here, so this gives you all of the options that you can turn on. And so for whoever was uh, asking about the real-time clock, right here is
Was me.
the real-time clock. So what you do is you simply copy this line, config RTC DSRTC equals Y. You copy that into the config micro IEC3 file, and it will recompile the code, and it will compile in the DS 1307 RTC functionality. So,
Cool.
yep.
Well, I have one more question, and I think this is probably a really good one.
Okay.
Is it possible to brick these devices?
It is not possible to brick the device.
Yay.
Yep. Um, so the bootloader always runs first, and so no matter how bad of a piece of code that you load on the device, the bootloader can always get you back to a runnable state. So you're good there. Now, one of the things you might have to do is if you end up with a corrupted image and it's a newer version, the version number is well, I take that back. There's code in the bootloader to check to see that the image it has to pass a CRC check. So the chances you're going to get a corrupted image are bad. But you can always get back to a known thing by doing that whole dev thing that I talked about earlier, where you do a dev build with the zeros in the version number, and then you can go forward to whatever version you want. So there's always a way to unbrick the unit. Always a way to get the unit back to an operating case. And the bootloader is not something that can be updated by the user. So in fact, that was a problem in some of the units that I was talking about that were sold kind of at a time when, when there was a ton of these different devices being manufactured and sold. Some of the people sold the units without a bootloader. And so the bootloader is, and I know that's probably a lot of people are like, what's a bootloader? But that bootloader is the thing that in the beginning, whenever you boot up the device, in the beginning, the code that runs is actually the bootloader, and it loads up and it looks at the files on the root of the directory or root of the card, and it looks for that newer version of the firmware, and if it finds it, it goes ahead and uploads the new firmware into the rest of the memory. The bootloader is the part that does that. So the main code doesn't do that, right? And that's the whole reason the unit can't be bricked. But you don't, when you build these devices, you don't have to put the bootloader on. You can just load the files on there, just like you're programming a microcontroller. Well, evidently some of the manufacturers, they just skipped the whole bootloader thing and they just loaded the code onto the microcontroller. Well, that was fine, but there's no way to update, and I guess there's no way to brick because there's no way to update the code, but there's no way to update the code, which is a big deal because there were bugs that were found back in the 2010, 2012 timeframe, which, stands to reason. And then these people were like, well, I need the new version of the code, but I put the files onto the SD card and I turned it on and it doesn't do that update thing. And we're like, yeah, well, it won't because it doesn't have the bootloader. And so that was irritating and annoying. And I think that's another reason why the thing got a bad name, is because that had nothing to do with the device. It had to do with those sellers that didn't kind of put out a finished device. The finished device should have a bootloader on it so that it can automatically update to the newest code. I haven't changed this bootloader since 2000, and I think I designed this device in 2008. 2008, I think, is when I made the design. And the bootloader, I took one of the existing bootloaders that was on the website and kind of tweaked it a little bit to run on this unit. And I haven't updated the bootloader since then. And so every one of the devices from 2009, 2008, 2009 on to today, they just continue to get updated, as new versions come along, which is really cool because the hardware is over 14 years old, but the firmware is, this firmware is, fresh and as of 2021. So that's the nice thing about a bootloader. I think that's the great piece of this that has created a lot of longevity for the solution. So I think it's a neat device. I was going to show you, I guess, before we close up. It looks like we've got our questions taken care of. I was going to pull out real quick here. I've got just kind of like a finish up with a little bit of history here. So I've got a original unit here. So this was, and I think somebody mentioned on the chat, but this unit, let me see, let me get back to my other thing here. Hold on a second. Yep, here we go. So this unit right here is the original. So this is the micro IEC, and as you see right there, it has an IDE drive connector, and then it has a CF card connector as well.
Yeah, I have two of those.
Yeah, I only think I didn't make a ton of those. I might have made 50 of them or so. And then this unit right here is the like, it's just a truncated version of that, which just has the CF card. There's no difference in the code for both of these units. It's just this unit does not have the it does not, well, okay, there you go. It does not have the IDE connector. But like I said, originally my idea was to understand how IDE drives worked. And then when I got this unit done and I figured out how IDE drive works, which is cool, by the way, then I realized that SD cards were smaller and cheaper. For some reason, CF cards got to be kind of expensive in the in the middle of the 2000s. I don't know what the deal was with their, but anyway, SD cards took over, and the rest they say is history. So I jumped on that bandwagon. But yeah, they used to be green, and this one, these still work. I could still update these to the newest code, and you can see the big chip right there, which is the same chip that's on this unit. It's just the chip is underneath right there, as opposed to on top. But anyway, those and I still get these sometimes. People sometimes trade them in on a micro IEC SD, so I have a few of these CF and ID units, but I don't sell them. I thought the other day about maybe doing a limited run of a new version of the ID unit, because it seemed like some people were interested in having really big ID drives attached to their Commodore, which I did for a while just for grins and giggles. I had oh man, I don't even know how many gigabytes of drive. I think ID drives tapped out at like 300 gig or 500.
They went up to terabyte.
Did they? Okay. Well, I know I had a 500. I had 500 gig ID drives, and I think for grins and giggles, I had a 500 gig drive connected to my Commodore for a little while. But I mean, it was usable, but I don't know that it was portable.
In an old CMD case, HD case. That was I used for quite a bit.
There you go. Well, hopefully this has been educational. Obviously, there's a lot of different devices. I'll be honest, there's been people that have been like, hey, you should design a cute little case for it, and that's fair. That's a fair criticism. Like I said, the device, I always intended that the micro IEC SD would be installed inside a unit. Like, let's see if I can pop this case off here. But so I always anticipated that it would, so that it would be mounted like right here. Right there at the back of the unit, or up through one of the cooling fins, because I think not on this unit, but on a bread bin, I think there's enough room to mount so it goes up straight through the cooling fins or whatnot. I always intended that it be mounted internally, and so the whole device here was really designed as kind of a tester, so you could get it up and running and make sure it works before you mounted it inside your computer and have it not work. And then you didn't know whether it was your wiring or whether it was a bad unit or whatnot. So that was always the intent. But I think the ones that, the SD2IEC units that look like little drives, those are really cute. And definitely, I mean, the code's fine on them. And if you have one of those units, and it has, some of the newer units are also moving into the 128K chips, like the 1284. This is the Mega 1281. There's a 1284, which also has that larger amount of RAM. So whoever was asking about partitions, if you get one of those machines and you can find out what AVR is on the machine or on the device, and it has 4K of RAM, let's say, then you should be able to recompile the code to have the larger number of partitions. So you can have your cake and eat it too. You can have the cute little 1541 drive looking unit, plus you can have your 20, 30 partitions that you want. But
that power cable was maddening. Oh my God.
Well, that's true.
If you wanted to put a disk drive with it, the pigtail wasn't long enough.
That's true.
Stretch out your cassette port.
So one of the things that, so it's updating here. Okay, so one of the things that it's interesting to see is there's a $ equals partition, I think is how you get it, isn't it? And that's the partition layout. So every so the system partition, that was something that was built in to emulate the CMD hard drives, and then you've got the main partition, which in this particular one is the little SD card, and it does not have a name. It doesn't have a volume name, so there's nothing in the name there. And then every one of the devices for a number of years has had what's called an EEPROM FS, a file system that's entirely in EEPROM. So you can store files in the EEPROM. So you can do an change partition 2 and then do a directory, and there's something right there. So then you can do a 10 print high. Whoops, I'll just do 10 print gem, and then 20 go to 10, and yeah, there we go. So it's adorable. Anyway, and then you can do save gem comma 10, and it will save to that EEPROM file system. And then what you can do is you can take your card out and reboot, right? So if you have, I don't know, something that you just absolutely need to make sure is always available on the unit no matter what, then what you can do is you can take the card out, and if you load the unit without the card in it, it automatically defaults to the EEPROM file system, which, as you can see, has the little program I wrote. So there you go.
That is so cool.
Yep.
I did not know that was there.
Yep. Oh, there's a whole bunch of stuff. I mean, I didn't go through a lot of things. The setting the time, changing the device number. There's a whole bunch of stuff online to do all those things.
The way it handles partitions.
Yeah.
I get how it works on the CMD drives. Are the partitions? Is it like if I put an SD card in and I've made however many partitions on it on the drive? Is that where it's going to show up? Or is it something slightly different?
No, it's however many. If you make partitions, it uses the master boot record, kind of the old master boot record partition. I can't remember what it was. Four primary partitions, and then one of those partitions can be an extended partition, and then you can use one of those primary partitions to create a big, huge extended partition that has a bunch of partitions
level of
in it.
success I've had with that is with the 512K cluster size. And then none of my partitions are greater than 4 gigs. I mean, I will actually just make 512 megabyte partitions, and that's what I run my BBS on, and that's ample enough space. But yeah, it's once you get them configured on the SD card and you get them in this device and you read them, just like he showed with the partition command, it's really just like a CMD hard drive. Exactly.
Yeah. One of the things that always drove me nuts with the CMD drives is the limit on the partitions, because if you had a 4 gig hard drive, you had to, in order to utilize all the space, you had to make 16 meg partitions.
Well, yes. So the key is you need to understand that on a CMD hard drive, every partition had to be what's called a directly accessible or directly addressable partition. So the way that Commodore's DOS was laid out is you had 3 numbers, and they're each 8 bits long. So you have the track number, you have the sector number, and you have and then each sector is 256 bytes. So if you have 250, and you can't have track 0, you can only have track 1. So you can have track 1 to 255, and you can have sector 0 through 255. So you can have the largest directly addressable partition you could have. Native partition was a partition that was 255 tracks, 256 255 tracks, 256 sectors each, and then each sector is 256 bytes. So it's 255 times 256 times 256. So it was like 256 bytes less than 16 meg is really what it was. And so then, and obviously because of the partitions, because the partition code, I think CMD only supported 1 byte for partitions. There was only 255 partitions you could choose. You can't do 256 because the 0 partition is used as the way the DOS works is 0. Well, no, I mean 0 is the system partition, but the reason that 0 is not used is because for compatibility, a lot of people would use load $0:$, and so you needed to make sure that 0 was really just meant the current partition. So 0 actually implies the current partition. That's the way CMD did it. So you could use partitions 1 through 225. So by the time you took, you know, all that together, that meant that a 4 gig drive was the max you could have because that was 2 to the 32, right? 4 gigabytes. But on the micro IEC, it does not, the main partitions, the partitions themselves are not directly accessible or directly addressable. They're just big chunks of space. And then if you want within those big chunks of space, you have the actual images, which are directly addressable, 1541, 7181, DMP, and whatnot. So they can be as large as you want them to be. Now, mind you, to the point made earlier, maybe you don't want them or need them to be that big because the software that you're using can't really handle that, right? Because a lot of times software assumed that there was not going to ever be more than 296 files in a directory, because that was the most that a 1571 could have. I think maybe there's a little bit more on a 1581, but there was a limit, right? And so I think some software was written to say, well, there can't be 500 files on a directory because that just doesn't exist. And so there's probably a software-based limitation. It's not the drive's limitation, but it's the software's limitation. And so you got to keep that in mind too. If you're going to use a BBS and the BBS says, I do not handle directories larger than 500 files, then you probably don't want to create file or partitions that can hold more than 500 files, let's say, because it'll just break the software unless you patch the software.
I found that out the hard way with the FAT16. You can only have 256 files in there based on just because of the limitation of the partition style.
There you go. So anyway, there's that, but there is no partition size limit on the SD2IEC firmware like there is on the CMD hard drives. It's you can make the partitions from the drive's perspective. You can make the partitions as big as you want.
And I can confirm that you can have as many files in there as you have space for.
That's right.
It'll slow down your directory read, but you can get them in there.
Yep. Okay. Well, obviously, I'm available via email. Obviously, another thing I should do is probably put my email address up there, but hopefully you all know how to get a hold of me via Facebook or the website or whatever. I'm happy to answer any more questions. But like I said, I do need to get ready to shove off tomorrow for New Jersey, and I got to pack a bunch of junk up. So I think I'm going to shut this down. Brad, I hope that gave you everything you're looking for. And if you have more questions, I'm happy to answer them later.
Thanks so much, Jim.
Okay.
Yeah, you have a great trip, Jim, and thank you for this.
No problem. Talk to y'all later.
Thanks, Jim. Bye.
Mm-hmm.